Hey everyone, today we're going to talk about predictions with probability. So again, when I post these slides online, just remember they're notes. You don't actually have to do anything with them. It's just to give you some examples of problems. Okay, so let's start with what are predictions with probability. Probability can be used to predict future events. How? By setting up and solving proportions. These are usually based on theoretical or experimental probabilities. So before I get into probability problems with prediction, I want to go over a quick review of how to solve proportions, because you'll need to know that or remember that for all of these problems. Okay, so there are multiple ways to solve proportion problems. The way I'm going to go over is basically solving a one-step equation. Okay, so one-step equation. Now, remember when we're solving one-step equations, basically the goal is to isolate the unknown variable. So like usually you'll see x for math problems, right? So we're solving for the unknown variable. To do that, we isolate that variable using inverse operations. Inverse operations. What I mean by inverse operations, if say we're adding something, the opposite of that would be subtracting, right? And if we're multiplying something, the opposite of that would be dividing, and vice versa. So let's go over an example problem. Let's say that we have, actually, really quick, let me just go over what proportions are. Proportions. Basically, they're equivalent ratios. Equivalent, I can spell. Equivalent ratios that you set equal to each other. For example, if we have the fraction 1/2 or the ratio 1/2, we could say that that's equal to 2/4, right? Because 2 is half of 4. We'd also say it's equal to 3/6, and etc. Okay, so let's go over an example really quick on solving the one-step equation. I'm going to use the awesome rainbow marker. Can I scoot over here a little bit? Okay, so let's say that we have the ratio 6:15. 6:15, okay? And let's say that we know it's equal to some number over 50, okay? So basically, we're trying to see, if you look up here, to get from here to here, we multiplied by 2. Multiplied by 2 on the top and bottom, right? So basically, we're trying to figure out what we're multiplying 15 by to get to 50, right? And then we would do the same thing on top, okay? The way that I'm going to explain this again is with one-step equations. There are multiple ways to do proportions and solving proportions, but I like doing this way the best just because it gets you in the habit of how to solve equations. Okay, so the one-step equation, again, we want to isolate the variable, which in this case is x. Okay, we want to get x by itself. Right now, let's look at what's happening to x. X is being divided by 50. So the opposite of that, instead of dividing, we want to multiply by 50. Okay? And remember, if we do something to one side of the equation, you have to do it to the other, right? Keep the balance in the force, Luke. Keep the balance. Okay? So, what I'm going to do is multiply this actually, I'm going to just rewrite this below so it's not so messy. Okay. Okay. 6 over 15 is equal to some number over 50. So again, isolating x, because it's being divided by 50, we're going to do the opposite and multiply by 50 to both sides. Okay. Now, what happens over here, I want to go over this. I don't want to just tell you that the 50 and 50 cancel each other out. I want to go over how that works. So if we have x over 50 and we're multiplying it by 50, really 50 is the same thing as saying 50 over 1, right? Anything divided by 1 is just itself. And with multiplying fractions, you just multiply across, right? So really we have 50x over 50. And now 50 divided by 50 is just 1, right? 1x, which is the same thing as just saying x. So that's how the 50 and the 50 cancel each other out here. So those cancel out. And let's use purple. Okay. So we're left with x on this side. Now over here we have 50 times 6 over 15, right? And we can do the same thing, put 50 over 1 and then multiply across, divide to simplify. You can also just on your calculator do 6 divided by 15, right? That's what the little fraction line means. So 6 divided by 15, and then multiply that number by 50, right? It's the same thing as this, equals x. Now, if we do that in our calculators, we will get a grand total of, let's use red, sure. A grand total of, let's see, 8. 8 equals x. Okay. Basically, again, how I got from here to here, 6 divided by 15 gives us 0.4. Multiply that number by 50 and you get 8. Okay, so the answer up here then would be 8. So 8 over 50 and 6 over 15 are equivalent ratios or proportional, right? So that's a basic gist of how to solve proportions. Okay, I'm going to go over some examples now with predictions. Okay, so again, probability is basically the likelihood of something happening. So what we can do is use probability, either theoretical or experimental probability, to predict the same kind of probability for future events or like bigger groups of people, etc. So let's go over some examples. First one, probability predictions example, rolling dice. So here, the probability of rolling a 6 on a number cube is 1/6, right? Just a regular dice would have 1, 2, 3, 4, 5, and 6. So probability of rolling a 6 is only one out of the 6 options, right? 1 out of 6 outcomes. Okay. So the question is, if we were to roll this number cube 50 times, we want to know approximately, or we want to predict approximately how many times the number 6 would be rolled, right? So we're rolling the dice 50 times over and over and over. How many times would we get a 6? So we're using this theoretical probability right here to predict what would happen with a larger number of rolls. Okay, so to answer these questions, basically there's a few other questions that you'll want to look at. Okay, zoom in so you can't see all the mess on the other side. Okay, all right, so what you would want to do for these kind of questions, basically look at the questions that I've asked you here in purple. Okay, so what is the given probability? So we were given the probability of you know, the number of favorable outcomes. Oh, did not mean to write favorite. Favorable outcomes, which in this case was 1. Oh, sorry. Over the total number of spins to get that outcome, which in this case would be 6. So for every six rolls of your dice, one of them theoretically will be the number 6. Okay, so that's the given probability, 1/6. Now we're going to set it up as a proportion in fraction form. So you might have already put it in fraction form. You could have put it in like ratio form like that, or written it out 1 to 6, etc. So once it's in fraction form, basically we're going to set it equal to the proportion of the given prediction question. So in this case, we have the total number of spins on the bottom, which here was 6. I'm just going to actually erase that part and rewrite it a little bit. 1, 6. Okay. So we're going to set it equal to what they gave us for the question. So we know we're now going to roll it 50 times. Instead of 6 times, we're rolling it 50, right? Which means the number that we don't know is on top of that ratio, that fraction. Okay, so we're solving for that unknown x, solving for the missing number x. Okay, so let's go through that one together. Let's scoot this up a little bit. Okay, so solving for x, 1/6 equals x over 50. Okay, we're going to do the same thing we did last time. So we know that x is being divided by 50 right now. So to get rid of that 50 on this side, to isolate x, get x by itself, we're going to multiply by 50 on both sides. Okay. So if we do that, again, the 50s will cancel out on that side. So we're left with x over here. So x equals, and then 50 multiplied by 1/6. Okay. So again, if you do this on the calculator, 1 divided by 6, this is basically what you would type out on the calculator, 1 divided by 6, and then times 50. Whoa, times 50. Okay, if you do that, you can either write it as the fraction 50 over 6, or you could write it as mixed number, 8 1/3. You could also write it as a decimal, 8.33. Okay, so that would be our answer. So if a number cube, a dice, is rolled 50 times, we would predict that it would land on the number 6 about 8 times. Okay. All right, let's go over another example. Free time. Johnny surveyed a group of random 7th graders as to whether they preferred video games, sports, or neither. Now, what I mean by random, I just want to point this out really quick. Random. What does random mean? Basically, it means you're not choosing people purposefully, right? So if I have a group of friends and I know they all like sports and I ask just that group of friends, that's going to be bias, right? I'm fixing the answer of the survey so that most people will like sports, right? So random is, it's pretty self-explanatory. Basically, random ensures that there is no bias, right? We're gonna choose names out of a hat, right? Something that you basically don't know who you're picking. Okay, it's random. Okay, use the survey results to make predictions for the entire 7th grade class with 350 students. That's an important piece of information right there. What is a reasonable prediction for the total number of 7th graders that prefer video games? So we're looking at this one right here. Okay. Now I'm going to post those questions up again right over here. Okay, what is the given hello. What is the given probability? So they give us the number 15 for the number of students who do prefer video games out of the survey. The bottom number would be the number of students total that were surveyed. So basically we're adding all of these numbers up. We want the sum of those numbers. 15 plus 22 plus 3. Okay, that'll give us 40. Okay, so we've done that. We set it up in fraction form. Now we're going to set it equal to the proportion of the given prediction question. So instead of just 40 kids, 40 students that we're surveying, we want to predict for 350 students. So that's why the 350 is on the bottom, because this is number of students, this is number of students. Okay, which means that the number on top there is what we don't know. Okay, so to solve this, go over here real quick. So we have our 15 over 40 equals x over 350. Now we're going to do the exact same thing we've done with the last two problems. To get x by itself over here, since it's being divided by 350 right now, we want to multiply by 350 on both sides to isolate x. Okay, so multiply by 350 on both sides. Again, you have to do it to both sides to keep the balance. Those 350s cancel out, so we're left with x on this side. And then if you were to do this again on your calculator, we would do 15 divided by 40. So 15 divided by 40. And then whatever that number is, we multiply it by 350. Okay, if we do that, we get the answer 131.25. So basically here we're saying that if we have 350 students total in the 7th grade class, based on these experimental results, we would predict that about 131 students would prefer video games total. Okay. All right. Last question. Fast food. Obviously, you got to throw in some food in there. Okay. All right. A fast food chain surveyed a random sample of students to determine what pizza they prefer. Cheese pizza was preferred by 40 students. So cheese is 40. And pepperoni was preferred by 28. So there's two different numbers there. Based on the results, how many of the 340 students can be expected or predicted to prefer cheese pizza? So key thing here, they do give us pepperoni pizza and cheese pizza, but we only want to look at the cheese pizza numbers. Okay, so as of right now, we know that 40 students preferred cheese, right? And the total number of students that were surveyed would be these two numbers put together. So 40 plus 28. That gives us 68. Okay, again, we want to predict for 340 students though, because this is the total number of students on the bottom. That's why we keep the number of students on the bottom over here. Okay, total number of students. This is the preferred part. Prefer here and here. Now we don't know this one yet, so I'm going to put x there. You don't have to use x. You could use any letter you want for your variable. All right, so we're going to solve it just the same way we've been doing with the other examples. So because x is being divided by 340 right now, to isolate it, we do the opposite and multiply by 340 on both sides. Oh, here we go. Again, those 340s will cancel out, and you're left with x equals 340 times 40 over 68. And if you were to do this in your calculator, you would get x equals 200. So the answer for this question then is, out of 340 students total, 200 would be predicted to prefer cheese over pepperoni. Okay, hope that helps. Let me know if you have any questions about this though.